Hello everyone, greetings of the day. Welcome you all for the 19th video of learning Swift programming languages. So these are the topics that we have covered from video 1 to 4, 5 to 8, 9 to 12 and 13 to 18. Let's move towards the today's topic. The first topic that we are going to see today is defer. That means it helps to execute a block of code regardless whether the scope is exited due to an error or return statement or normal control flow. We know that in Swift, every code will be executed in a linear manner, that is a top down. So here I have provided three print statements. The first one is opening a file, closing file and processing a file. This is a function with one input parameter and this is the function call. So if I call this function, you will be getting the result as initially the opening file, this print statement has been printed, and then the processing file has been printed, and after that only the closing file is getting printed. This is because this print statement I have been kept inside the defer block. So this defer block will be executed whenever this function got exit or the current scope is getting exited. Wherever we have provided this defer, while that scope getting exit, at that time only this defer will be called. This defer will be called even this function is exited with an error or with a return statement or normal. So that is the explanation of this defer. So whatever the cases, this defer will be executed regardless of the outcome of this function, whether it may be an error or it may be a return statement or like this a normal flow. So whatever the case, this defer block will be executed. So that's the purpose of this defer. The second topic that we are going to see is higher order function. The definition of this is functions that accept other functions as arguments or return type. So this is called higher order function. See, this is a function, operate on numbers. This function is taking this operation. This is a function. So this function is taking as an argument of operator on numbers. So that we'll be calling this operator on numbers as higher order function. That is functions that can accept other functions as arguments or return type, that are called higher order function. See here what we have done is we are accepting three parameters for this function, that is a is an integer, b is an integer and c is an function, and we are returning an int value here. Here we have defined other two functions like add and subtract. This is of the same type of this operation. So it is accepting two integers and returning one integer. Accepting two integers here a and b and returning one integer. So here we are calling that result add is operate on numbers here. So three parameters need to be provided. First one is the a 5, b is 3 and then the operation. This operation we are providing as this function add. This is equivalent to calling add of 5 comma 3 and will be result is printed here. The same thing we have done for subtraction as well. So our result will be addition result is 8, subtraction result is 6. See, so it will take 5, 3 and this operation here, and this operation will be executed here, that is the add function. This function will be executed in this place and returning this as a result, so that we'll be getting that additional result is 8 and then the subtraction result is 6. So this is about the higher order function. These are the commonly used higher order functions: map, filter, reduce, sorted and for each. So let's execute this and see the result. So if we use the map for each element of an array, we can do the functions. That is, here we are doing multiplying each element of an array. So we will be getting the result as double of it, 2, 4, 6, 8 and 10. So that is the usage of this map function. The next one is filter. We are filtering out the even numbers here. So this is the condition I am provided in the each element of the array. I am checking is it divisible by 2. If it is, means I am passing it, or else I am blocking that result, so that I am getting the result as 2 and 4. The next function is reduce. Here for this reduce, we are using two parameters. That is inside the bracket 0 and then one operator. So this operator will add what all in this provided array will be added. After adding this value will be added to the total. So here 1 plus 2 plus 3 plus 4 plus 5 is 15. After the result of 15, it will add this number again. So if I am going for value of 5, so then the output will be 20 here. See, 15 it will be added, and after that in final, see here the number is 20. So this is reduce is doing. And then the sorted. So here I have provided in an jumbled way. So if I sort this, it will be sorting in the ascending order. That is the result I am getting as 1, 2, 3, 4 like this. In the ascending order, this will be get sorted. So only I want to provide this dot sorted function. The last one is for each. In this, it will be printed as each item will be printed in a separate line. So that is the use case of for each. The third topic that we are going to see is escaping closure. The definition of this is if a closure want to outlive the scope of a function, then we call as escaping closure. So before that, I will explain what is non-escaping closure so that you will be understanding more about the escaping one. Here I have defined two functions, that is the add two numbers and perform addition function, and I have called the add two numbers function here. So initially I have a print statement. This is the step 1 will be printed. After that, this function called here, it will be having two parameters, actually three parameters. There is a number 1, number 2, and the third parameter is a closure. So that's why I have provided in the syntax like this. So the third parameter, that is the closure, it will be accepting a parameter and returning void. So inside the closure, while it execute, just will be get the print statement. So while executing this function here, after printing the step 1, we will be getting the step 2, and then the sum will be calculated from the parameter numbers what we have provided. After that, step 3 will be printed, and then this completion is passing the parameter of sum, so that this completion will reach here and this result will be printed, and then the last step. So if I execute this is the result you will be getting. So initially step 1, and it will go to this function. Step 2, it will calculate the sum. Step 3, and it will call the closure. So it will reach here, and you will be having the result is this value will be printed. After that, this function has been completed, and last step. So here this closure, that is the completion handler, does not want to outlive. That is, we are getting the result within this function itself. See, this is the function. Within this function itself, this completion handler closure is executed. So we don't want to make this closure to outlive outside the scope of this function. This is called non-escaping closure. Let's see how the escaping closure will be. Now, instead of
calling the closure here, we are making our closure to wait for half a second. So in this case, it is asking to make our closure as escaping. So we need to mention as escaping for our closure. So in this case, if we run our application, it will be going as step 1 will be printed, and then it will be reaching the function here. Step 2 will be printed, step 3 will be printed, and again if it reach here, it is asking to wait, so that it will be waiting. By the meantime, it will be exiting this function and go for the last step. After that only we'll be receiving the result. So in this case, we are outliving this function. See here. So the step 1 is printed, 2, 3, and after that last step is printed. That is, this function is getting over now. After printing the last step only, we are receiving the result is. That means we need to make this closure to outlive this function. This function execution is over now. After that only we are receiving this print statement, and then we are making the closure to run. This is what I mean by escaping closure. This closure escape the lifetime of this function, and after that it is executing. Where this is useful means in the network calls, because in the network calls, when we hit the server and get back the results, it will take some time. So in that cases, our function will be exited, will be moving to the other parts of our function. So at the time of it is reaching back with the results, we will be executing that closure. So in that cases and all, escaping closure will be mostly useful.
The next topic that we are going to see is KVC, key value coding. That means it allows to access an object's property indirectly. See, here we have a class of student with the property name. Here, this is the usual method I have explained here. So I have created an instance, and with that instance, using the dot syntax, I have been accessed the ONG. And after that, I have been assigned the name student with that instance name. If the same method, if I need to go with the KVC means, I need to mark this class as NS object and this property as at objects C and dynamic. And if this is the case, I can access that property using the KVC method. See, this is the KVC method. This is for setting the value. Here I have set the value using the dot syntax, but here the same instance I'm using the dot set value. This is the new value I have been added. For key is name. So this name is the property. I'm here using as a string value, using strings. That is the KVC is doing. So here is setting the value, and here it is assigning. See this line. Instead of using the dot syntax for the instance, I'm using my student dot value for key. So this value will be assigned into the new name. So these two steps, that's the usual thing we are doing. Instead of that, I have been used in the KVC method. The implementation of this KVC method will be there in the UI framework and in the JSON things and all. You just try to understand what KVC is. So, and the implementation part, while you'll be practically working on, you'll be understanding, okay, the purpose of it. Along with the KVC, we need to know about the KVO, that is the key value observing. The main purpose of this mechanism is to observe the variables. We have studied about the will set and did set. These are the property observers we have learned before. The same thing this KVO is also doing. The major difference is it is outside of the type definition. This property observers we will be defining along with the property here itself. Whenever we are defining a property of an class, there itself we will be defining the will set and did set. But this key value observing we are defining outside it. See, this is the definition. So this is the instance I have created for the class student. I'm observing it. What to observe? Because we may have a lot of properties for a single class. So I want to observe the name property of this student class. So that is what I have explained here. And what to observe. So I can simply have a dot old or new, like dot new or dot old I can keep. But if I want to observe both the things, that new and old, we can have in the options. And here in this closure it is taking that the new change, new name and the change. See, change dot old value, change dot new value. Whatever the changes I have been made here, immediately this closure will be executed and we will be getting the results. If I execute this, you will be seeing the result as, see, I have changed the names in the usual way as well as in the KVC way, the two methods. So initially the old name, whenever I change the property here, immediately this closure will be executed and will get the statement as old name is the old value. That is, here I have provided the new OMG. So the old value and then the new value. Again I'm setting for the new value. So then the old value will become Vivek and then the new value become the value I have been added as the new MG score. So this is to know about the KVC and KVO. The next topic that we are going to see is Hashable Protocol. We have seen about the protocol before. This Hashable Protocol means it will generate a hash value for instances. See, here I have defined a person structure with Hashable Protocol. Here, this is the implementation of the structure, and here I have created three instances, person 1, person 2 and person 3. And here I am printing the hash value. Hash value is nothing but a value, a integer value will be provided for each instances. So if I run this, you can see that person 1 dot hash value and person 2 dot hash value both are different. Instead of person 2, if I'm adding the hash value of person 3, because see the instance of person 1 and 3 both having the same parameters, Alice, and the age is 30. In this case, if I run for the hash values, I'll be getting the same value for person 1 and 3. So this is about the hashable protocol. So it will create a unique value for the instances. If the both the instances are same, it will provide same value for those instances. The next one is of Equatable Protocol, that is used to define the equality of instances. See here I have defined a structure of my struct that will be having two properties and here created the three instances. See, the instance 1 and instance 2 is having the same values for properties. So in this case, if I equate like this, I'll be getting the output as true, and the instance 1, if I equate with the instance 3, they have different values, so I'm getting as false. So like this, equating the instances in this manner is the feature of Equatable Protocol. The next topic that we are going to see is comparable protocol. Before this, we have seen the equatable protocol, that is, we are equating two instances. Here also, I have defined the my struct. It is adapted to comparable protocol and it is having one value. Here are the two instances. Here I am comparing the two instances with an operator, and based on this I am getting the result. So if I execute this, I will be getting that. So it is of value 5 and 10. So instance 1 is less than instance 2. This is getting executed. So Before this, we have equating two instances. Now we are comparing with an operator. So this is about the comparable protocol. The next topic that we are going to see is generics. This helps to write flexible and reusable functions without explicitly mentioning the type. We can write the function. See the swapping function here I have mentioned. I didn't mention any type explicitly, so that it will be swapping the values provided for the a and b interchangeably. So here I have provided two strings. So if I execute this, I'll be getting the result as before swapping. So these are the values for x and y, and after swapping you can see the results. So if I want to change this to some integers, in this case also it will be working perfectly. Without mentioning the type, we can able to provide a single function in order to use in every cases. So that is the use case of generics. This cannot be implemented not only in functions, it can also use for the structures or classes as well. This is about generics. The next topic that we are going to see is singleton. It's kind of a design pattern. That is, we are making a class that will be having only one instance, and that instance we will be using throughout the application. See, this is my class with the name of my singleton. Here I have made a property with a static. So this I have been initialized with this class. Because of making this initializer as private, we cannot able to make an instance for this class from outside. So that we have a function here. This function can be accessed only through this method. That is, this shared property have been initialized with this class. In order to access this shared property, as this is a static, we can use with the class name, that is my singleton dot shared. After that, we can access the function of it. The usage of singleton is it is initialized once, that is the instance is created once, and throughout the application we are using that instance. This is about the singleton. The major singleton that we are using in the Swift is user defaults in order to persist the data locally. The next topic that we are going to see is dependency injection. Dependencies, we can consider it as an external object. So the explanation of this is we are injecting external objects into another object instead of asking the object to create external object inside. So it seems to be complex, but I'll explain it. See, here I have a class request manager. Consider this as an external object. Okay. Here another class of view controller. So while I create an instance for this view controller, this external object is created inside this class. So here we didn't use any dependency injection. So understand this example first. So here we have an external object of request manager. While I creating an instance for this class of view controller, then instance for this external object is created inside this view controller. So this is not a good habit of coding, because in the later stages of code, if we want to pass the subclasses of this request manager here, we cannot able to do. So in order to consider the reusability of the code and for the easy testing purpose, we will be using the dependency injections. So dependency injections can be attained with three methods. Like we can do the initializer injection, property injection, and method injection. So here I have explained about the property injection. So you consider the concept of dependency injection, and the way of injecting will be the three types. That's all. So see, here I have used the dependency injection. That is, we have another view controller here. It will be having a property, and that property is of the type request manager, and I have kept it as an optional. So while creating the instance for this another view controller, I'm passing this request manager. That is, the instance for this request manager is creating outside this class. See, inside this class, I'm not creating an instance for the request manager class. I have created an instance here. With that instance, using the dot syntax, I'm accessing this property and assigning the object for request manager class. So this is about the dependency injection. With this, we are wrapping the session for today. Thank you.